Okay, so this lesson is called graphing parent functions. Okay? So the unit is called families of functions. So in mathematics, a family of functions, that's its first definition. Family of functions is a set of functions defined by the same type of formula. Okay? We are going to focus on the following families in this unit. We're going to do linear functions, quadratic functions, cubic functions, square root functions, cube root functions, absolute value functions, and exponential functions. So each one of those is called a family of functions. And the lesson is called parent functions. This next definition is parent function. In math, a parent function is the simplest function of a family of functions that preserves the definition or shape of the entire family. Right? So we're going to graph 7 parent functions today in this lesson. This first one, graph f of x equals x, this is called the linear parent functions. Let's write that down. Okay? This is the linear parent function. So we're going to graph all these parent functions, and I want you to commit them all to memory. Okay? So we're going to make a table for this, and then we'll graph it. So let's make a table. We'll put x, and then f of x or y. Okay, so here we go. Okay, so when x is negative 3, let's do negative 3. When x is negative 3, f of x equals x. So if x is negative 3, then f of x is negative 3. I'm going to do some negatives. I'm going to do 0 and some positives in this table. When x is negative 2, f of x equals negative 2. When x is negative 1, f of x equals negative 1. When x is 0, f of x is 0. When x is 1, f of x is 1. A little bigger. When x is 2, f of x is 2. When x is 3, f of x is 3, and so on. Okay? So that's what I'm going to use to make my table, to make my graph. Okay? Negative 3, negative 3. Then we got negative 2, negative 2. Then we have negative 1, negative 1. 0, 0. We got 1, 1. We got 2, 2. And we got 3, 3. So let me draw that line. Should look like that. And that is the linear parent function. So every other line that you graph is going to be based off of this. Okay, this is the linear parent function. And the next lesson, we're going to shift these around, left, right, up, down, make them skinnier, make them fatter, and so on. So the next lesson is going to be transforming these around the graph. But every single line is based off of this. This is the linear parent function. This next one, graph f of x equals x squared. This is called the quadratic parent function. This is the quadratic parent function. Okay. So again, I'm going to make a table, then we'll graph. So for my table, put x, put f of x. In my table, I'm going to put some negatives for x. I'll pick 0, and I'll pick some positives. Okay, let's start with negative 3. Okay. When x is negative 3, f of x equals x squared. So you're going to do negative 3 squared, and you get 9. Okay? How about when x is negative 2? You're going to do negative 2 squared, and that's 4. When x is negative 1, we're going to do negative 1 squared, and that's 1. When x is 0, 0 squared is 0. When x is 1, 1 squared is 1. When x is 2, 2 squared is 4. And when x is 3, 3 squared is 9. So I think that's good enough for our table. Let's graph it now. Okay. We got negative 3, 9 first. So negative 3, 9. Next we got negative 2, 4. Negative 2, 4. Then we got negative 1, 1. We got 0, 0. We got 1, 1. 2, 4. And 3, 9. Let's graph that. This is going to be a U shape, not a V shape. Okay, so make your graph look kind of like a U shape. And this is the quadratic parent function. Now you want to commit this to memory because the next lesson is going to be shifting this around the graph. So try to have this shape memorized. Okay. This next one, f of x equals x cubed. This is the cubic parent function. Cubic parent function. So again, let's make a table, and then we'll graph it from the table. Okay. Again, I'm going to pick some negatives. I'll pick 0. I'll pick some positives. So let's do negative 3. Let's do negative 2. Let's do negative 1. 0, 1, 2, 3. You don't have to do these points, but I'm going to go with them because I know what the shape is ahead of time, so I'm trying to pick good points. When x is negative 3, f of x equals negative 3 cubed. That means negative 3 times negative 3 times negative 3, which is negative 27. So that's not going to fit on our graph, but no problem. Okay. When x is negative 2, negative 2 cubed means negative 2 times negative 2 times negative 2, which is negative 8. Negative 1, so negative 1 times negative 1 times negative 1 is negative 1. When x is 0, 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So that's not going to fit on the graph either. So we'll graph these 5 middle points. Okay. So 0, 0. Got 1, 1. We got 2, 8. Then we had negative 1, negative 1. And we had negative 2, negative 8. Right. So this is going to be the graph right here. That is the cubic parent function. So again, try to commit the shape to memory. It'll be helpful going forward. Example 4, graph f of x equals the square root of x. So this is the square root parent function. Let's write that down. Square root parent function. So let's make our table, and then we can graph. Now for this one, you got to be smart when you make the table. So let's think about it. I'm going to choose x. For x, I'm going to choose 0 because I can easily get that square root. The square root of 0 is 0. Next, I'm going to choose 1 because I can easily get that square root. The square root of 1 is 1. The next one I'm going to choose is I'm going to choose 4 because I can easily do the square root of 4. The square root of 4 is 2. Next, I'll do 9 because I can easily do the square root of 9. That is 3. And I'm going to graph those points. So 0, 0. We have 1, 1. We have 4, 2. And then we had 9, 3. Let's draw that graph. Make it look nice. It should look like that. Okay, so that is the square root parent function, and you want to commit that to memory too. It'll be helpful in the next lesson. So that's square roots. Now we're going to do the cube root parent function. Okay, this is going to be called the cube root parent function. So I'm going to make my table right here. And then we can do the graph. I'm basically going to be working backwards with this table, just like I did with the square root one, okay? So you can only take the square roots of positives. That's why I chose 0, 1, 4, and 9, no negatives. But you can do the cube root of negatives, okay? Because, think about it like this. I'm going to start with 27, and I'm going to do negative 27. So the question is, what is the cubed root of negative 27? What number can I multiply by itself 3 times to get negative 27? Can you think of it? Pause the video if you want. Okay? The answer is negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. The next one I'm going to choose is I'm going to choose negative 8. Because I can easily get the cube root of negative 8. Because what number times itself 3 times equals negative 8? The answer is negative 2. Because negative 2 times negative 2 times negative 2 equals negative 8. Next up, we got negative 1. The cube root of negative 1 is negative 1. Because negative 1 times negative 1 times negative 1 equals negative 1. The cube root of 0 is 0, because 0 times 0 times 0 equals 0. How about the cube root of 1? What number times itself 3 times equals 1? The answer is 1. How about the cube root of 8? What number times itself 3 times equals 8? The answer is 2. And let's just do one more, just to be symmetrical. The cube root of 27 means what number times itself 3 times equals 27? And the answer is 3. 3 times 3 times 3 is 27. So now we'll graph these. You won't graph the ones with negative 27 and positive 27. We'll graph the middle 5. Okay, so let's graph the middle 5. 0, 0. We have 1, 1. We have 8, 2. We have negative 1, negative 1. Then we had negative 8, comma, negative 2. So draw your graph. Make it look nice. It should look like that. Now, I sound like a broken record, but try to commit that to memory as well. Okay? Okay, let's go to the last page. We have 2 more examples. f of x equals the absolute value of x. This is called the absolute value parent function. Okay, absolute value parent function. So again, let's make a table, and then we'll graph it. So for the x's, I'm going to choose some negatives. I'll choose 0, and I'll choose some positives. So like this. Okay. The absolute value is how far away a number is from 0, and it's never negative. Okay. So if I said the absolute value of -3, that equals 3. The absolute value of -2 equals 2. It's never negative. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2, and the absolute value of 3 is 3. So we're going to graph these. So -3, 3. -2, 2. -1, 1. 0, 0. 1, 1. We had 2, 2. We had 3, 3. Now this one is going to be a V shape. The quadratic parent function was a U shape. This one's going to be a V shape. And again, try to commit that to memory. Now this last one, this is going to be called the exponential parent function. Whenever you have a variable as the exponent, that's an exponential. Now we could also do this for 3 to the x power, 4 to the x power, 5 to the x power, 1/2 to the x power, 1/3 to the x power. I chose to do 2 to the x power today. I'm just going to show you what this looks like. I'm going to make a table. I'll pick some negatives, I'll pick 0, and I'll pick some positives for my table. Okay, so I'll pick those x's for my table. I did -3, -2, -1, 0, 1, 2, 3. Let's do the easy ones first. When x is 0, that means you have 2 to the 0 power. Do you remember what that is from Algebra 1? The answer is 1. Anything to the 0th power is 1. So 2 to the 0 power is 1. If I said 5 to the 0 power, that's 1. 18 to the 0 power is 1. Anything to the 0 power is 1. The next one, when x is 1, 2 to the first power is 2. That one's easy. When x is 2, 2 to the second power is 4. When x is 3, 2 to the third power is 8. Okay, now these might be a little tricky, so I'm going to do out the work down here. Okay, so I'm going to do out the work down here. When x is -1, when x is -1, that means we have 2 to the -1 power. 2 to the -1 power equals 1 over 2 to the 1 power, which is 1/2. When x is -2, let me do that down here. That means we have 2 to the -2 power, which is the same as 1 over 2 to the +2 power, which is 1/4. When x is -3, that means we have 2 to the -3 power, which is the same as 1 over 2 to the +3 power. These are exponent rules, which equals 1/8. Okay, so now we can make our graph. Let's do the positive ones first, because that's easy to graph. 0, 1. We have 1, 2. We have 2, 4. We have 3, 8. We have -1.5, just estimate. That's good. -2, 1/4. -3, 1/8. So the graph is going to look like this. Let me just draw it first. That's not perfectly drawn, but this is what the graph is going to look like. It's going to approach 0, but never actually touch 0. We will learn more about that when we get to the unit on exponentials later in the year. So that is the parent function for exponentials. And again, try to commit that to memory. Try to commit all of these to memory. It will be easier when we get to the next lesson. And that's the end of that lesson. That was graphing parent functions.